Hi there everyone, my name is Fatima Amjad and I'm here to talk about my project, which is Pakistani Phrasal Sign Language Classification using surface electromyography. So now let's jump into the video and talk more about it. More than 278 individuals are born on Earth every minute. Each of these people have different personalities and traits, and no individual on Earth is the same, but there is a group of individuals who are different than the rest of the population. These individuals have disabilities that make them stand out as special. For the sake of this video and project, we will talk specifically about people with hearing and speaking disabilities. Statistics show that 5% of the world population, or numerically speaking 446 million people, suffer from hearing disabilities, out of which 34 million are children. These individuals find it difficult to communicate with the world, and for children, being unable to express themselves can be a major unhealthy mental growth factor. These individuals use a special language known as sign language for communication, which comprises of various gestures. Although this helps a lot, but there still remains a communication gap, as sign language is not understood by everyone. In order to help bridge this gap, we made an attempt to develop a system capable of converting sign language to speech, so that these individuals can communicate with the world easily. This project focuses mainly on Pakistani sign language, just like our linguistic sign language also varies from one country to another. The main purpose of this project revolves around the concept of taking electromyography signals from the forearm and using various signals processing techniques to convert it to speech. The very first step was to acquire EMG data from the forearm, which is obtained due to the flexion and compression of the muscles. So, a total of 11 phrase gestures were selected and were collected using the BIOPAC system, which was present in our laboratories, and the signals were connected from the forearm. And each signal was 10 seconds long, and a total of 50 signals per phrase were collected. The signals acquired were in the raw form, comprising of various noises in the form of, let's say, motion and etc., which needed to be removed, and for that purpose a technique called empirical decomposition was used. Now, after cleaning out our signal, the next step was to do a technique known as feature extraction before classifying the data, and for that we used a total of 11 features: skewness, standard deviation, kurtosis, crest vector, shell energy, spectral crest, spectral decrease, spectral flow, and LTPs ranging from 1 to 9. Now, after extracting the features, the signals needs to be classified, and for that we used machine learning, specifically supervised machine learning. What machine learning does is that it recognizes the data, and according to its class, it separates it out, and it can be used to classify various forms of signals or data that we provide to the system. Now, for this project specifically, we used a machine learning algorithm called sport vector machines. And what sport vector machines does is that it classifies the data set linearly by developing hyperplanes between various classes. So now that our system is ready, we need to test it, and we need to check the results that are obtained from this system. Now, jumping on to the result bandwagon, what we saw is that our system showed us an accuracy of 85% with an error of 15%, and we tested our system upon 5-fold cross-validation. So the confusion matrix showed us the true positives and the false negatives, which clarified which signals were classified the best and which were not. So what this system does specifically is that it helps to bridge the gap between the disabled and the normal people. The second thing, it is focused only on Pakistani Sign Language, and it is very simple and has a very less time complexities. Thank you for watching this video, and if you want to watch more content from Intelligency, subscribe to our channel and look at the link in the description for more videos. Thank you so much. Take care. Bye bye.